Okay, let's continue. Number 5. This is a simply supported beam, and its EI has been given, and some dimensions is given. You're requested to determine the deflection at the midpoint due to the concentrated load P. Well, this is a simple one. You just directly use the equation, a elastic curve. Right? This when you have a simply supported beam, and the P is added here. Right, you're requested to calculate the deflection here in the middle span. So in this case, you just need to determine A and B. Right, the A here is 6,800 mm, and B here is equal to LCD, that is 3,000 mm. Then the equation we'll need to use will be this: the delta x or Vx equals P by Bx over 6L EI by L square minus B square minus X square. So here in this case, X equals 4,900 mm, and B is 3,000 mm. L is 9,800 mm. Also our P equals 38 kilonewton, that is 38,000 Newton. So this equation will be 38,000 by 3,000 by 4,900 over 6 by 9,800 by 67,000 by 10 to the 9th, then by L square, that is 9,800 square minus 3,000 square minus 4,900 square, and then you will get 8.94 mm. So that is C. Number 6. Number 6 is a cantilever beam, where you have a distributed load between A and B and a concentrated load P at the end, at the free end C. However, you are not requested to calculate the deflection due to the combined loading. Well, read this question. Determine the beam deflection at point C, the free end, due to the distributed load W. So only due to the distributed load W, so you can ignore this P. So this P here, you can just delete it. It's useless. Okay, here's in this case, so after the deflection due to this distributed load W, this beam section AB from A to B will deflect in this way. Then here you will have a delta 1. Then you can determine that here you will have a angle determine here is theta, and you need to determine another delta 2. And here this length will be BC or B. Right, so here just select the correct equations. The delta 1 can be calculated simply by the equation that is negative WL4 over 8EI. Here, of course, the L equals A. So this can be calculated as negative 21 by 2.2 to the 4th over 8 by 62,000. This is negative 0.00099, but the unit is a meter, or negative 0.99 millimeter. And here we can use that equation in the same row to calculate the theta. Whether the theta equals minus WL cube over 6EI. This is negative 21 by 2.2 cube over 6 by 62,000. So this is negative 0.000601 radian. So this is in that triangle. You can calculate the delta 2. That will be B by theta, since the theta is a very small angle. Right, so this is negative 1.7. That is B, right, by 0.000601 equals negative 0.00102 meter, or negative negative 1.02 mm. So the overall deflection delta will be delta 1 plus delta 2. That is negative 0.99 minus 1.02. That will be negative 2.01 millimeter. Okay, the answer is C.